Alright, so this is going to be from the Rotational Dynamics Quiz 3. This is version D. It states that a wheel has a radius of 0.4 meters. Attached to it is a block, and this block is going to descend 1.5 meters in 2 seconds. It is starting from rest, and the tension in the string is 20 newtons. When I see this problem, the first thing that comes to my mind is I'm going to set up my Newton's second law equation, and I know that I need to find the acceleration for the center of mass using torque. So first I'm setting up sigma F is equal to ma. Our forces on the block are going to be the force of gravity minus the opposing force tension is equal to ma. And to solve for a, I'm going to set up torque because I'm used to doing pulley problems this way by finding acceleration. So I have the sigma torque is equal to F times a perpendicular radius is equal to I times alpha. So our F is going to be our tension times our radius is equal to, and then we can rewrite our moment of inertia as 1/2. I'm going to label this M2, which is the mass of the pulley, times R squared, and then I just changed alpha to A over R using the gateway function. So now I'm going to plug in some numerical values. Our tension is going to be equal to 20. Our radius is going to be 0.4. We have 1/2. We still don't know M2. Our radius right here is going to be 0.4 squared. And then we have A over R, which is 0.4. As you can see, that 0.4 cancels out with the 1 in the A, and then that one cancels out across. So we have the radius cancels out all around. So we have 20 is equal to M2 times A over 2. So we have 40 is equal to M2 times A. So our acceleration is going to be 40 over M2. And now we can go ahead and plug this back into our Newton's second law equation. So for Fg, I just rewriting this as M1g, M1 being the mass of the block, minus the tension of 20 is equal to M1 times 40 over M2. I'm just going to stop right here because this problem is unsolvable. As you can see, we have two unknown variables, M1 and M2. So using torque would not be the right way to go about this problem given what we're given. So don't just assume that problems have to go one way because you're used to doing them. There are different ways to solve problems. So for this one, we're actually going to use kinematics to find our acceleration rather than torque. So the kinematics function I'm going to use is displacement. So we have the displacement is equal to our initial velocity times time plus 1/2 acceleration t squared. We're going to plug in our values. Our displacement is 1.5. We start from rest, so that's 0 times our time of 2 plus 1/2 a times the time of 2 squared. This simplifies to being 1.5 is equal to 2 times a, so we get our acceleration to be 0.75 meters per second squared. And then we can go back to our Newton's second law equation and we could actually solve for it now. So we have sigma F is equal to ma. Our forces are still going to be Fg minus T is equal to ma. I'm going to rewrite Fg to be 9.8 times m since it's gravity times mass. Minus our tension of 20 is equal to, and then A is going to be 0.75 times the mass. And then we could rewrite this to be negative 20 is equal to negative 9.05 times m. And then we simplify to get our mass to be 2.2 kilograms for this pulley problem.